Hey students, we are doing 2024 paper 2, May-June variant 3. I have done first 10 questions in my previous video. Start from question number 1, question number 11. Question number 11 is hydrogen, oxygen, fuel cells, and gasoline are each used to power cars. Which statement describes an advantage of using hydrogen fuel cell in cars in comparison to gasoline engine? It's really easy because as gasoline engines contain hydrocarbons, and hydrocarbons, upon burning, they produce carbon dioxide and water. So carbon dioxide is a toxic gas, and because to reduce carbon dioxide, people prefer to use hydrogen oxygen fuel cell. But they are expensive. The drawback of hydrogen fuel cell is that they are expensive, they are difficult to use, hydrogen is difficult to store, and the hydrogen fuel cells, they give lots of energy, like large amount of energy is released, which is only used for longer distances and in big vehicles. The advantage of hydrogen fuel cell is hydrogen fuel cell do not release carbon dioxide. This is the biggest advantage of using hydrogen fuel cell. Next, plant cells use energy from sunlight for photosynthesis. Which row describes and explains the energy change that occurs? Now, plant cells use energy from sunlight for photosynthesis, means they absorb energy from sunlight. This makes the type of reaction endothermic. It's an endothermic reaction because it is absorbing the sunlight. It is absorbing the energy. Now, the explanation is for endothermic, less energy is released in making the bonds than absorbed to breaking the bonds, or more energy is released making the bonds than absorbed to break the bonds. As it is an endothermic reaction, so overall it's endothermic, means overall the energy is absorbed. So obviously it means the energy absorbed will be more than energy released. Energy absorbed. So here, less energy is released, making the bonds than energy absorbed. So energy absorbed is more and energy released is less. So this makes option A the correct. In the next question, two different experiments are done to find the enthalpy change delta H of each reaction. The temperature of each reaction mixture is measured at the beginning of the reaction and after 3 minutes. Which row gives the correct sign for the value of delta H for each experiment and identifies if the reaction is endothermic or exothermic? Okay, so we have to see the sign of the delta H. Is it going to be positive or negative? And if it is positive, it's going to be endo. If it is negative, then it will be exothermic. So let's see the temperature change from these thermometers. For the first one, for experiment 1, initial temperature is 26 degrees. And the final temperature after 3 minutes is 17 degrees. So as you can see that the initial temperature is 26, but after the reaction, the temperature is 17. It means the temperature is decreased, and the temperature decreases in endothermic reaction. So it's going to be positive. Experiment 2, the initial temperature is 24 degrees, and the final temperature after 3 minutes is almost 40. We'll consider it 39 or 39.5 or 39.8 because it is a little bit lower than 40. It's not fully 40. But the point is that the initial temperature is low and the final temperature is higher, which means that this is an exothermic reaction, and because the temperature increases in exothermic reaction, the temperature of the surroundings. So it's going to be negative. Let's see. The answer in experiment 1, it's positive and endo. In experiment 2, it's negative and exo. So C is the answer. Next question, the reaction pathway diagram for an endothermic reaction is shown. U, V, and W are the known energy values. So this is the energy level diagram. You can see energy pathway diagram for the endothermic reaction. The reactant's level is already very low. They absorb the energy from outside. They absorb the energy, and then the product's level is higher. Which diagram shows the reaction pathway diagram when a catalyst is used in the reaction? What does catalyst do? A catalyst lowers down the activation energy. Lowers down the activation energy. Now, first of all, we'll see what is the activation energy. It's the minimum energy which is required to for the reactants to turn into products or to start a chemical reaction. The proper definition of activation energy is the minimum amount of minimum energy needed for the reacting particles or the colliding particles to react. So the minimum energy which is needed for the reacting particles for the colliding particles to react with each other, this is called the activation energy. And the activation energy here is between the reactants and the peak of the mountain. So this is the activation energy, and it's already very, very high. You can see. When we add a catalyst, the activation energy gets lowered down. So we will get the alternate way with lowered activation energy. A, is A correct? Is B correct? C or D? I'll make it small for easier. The alternate way is C, because here the activation energy is being lowered down by the catalyst. So C is the answer. Next, which process is a physical change? Burning a piece of magnesium, reacting calcium carbonate with hydrochloric acid, melting an ice cube, and rusting of iron nail. Melting an ice cube, because melting is a physical change. In a physical change, no new substance is formed. No new substance is formed. And as we can see that in melting, when we're just melting the water, melting the ice, the H2O still remains H2O. It has not changed. H2O in the solid form will change, it will melt into H2O in the liquid form. When the ice changes into liquid water, the H2O will still remain H2O. The substance will not change. That is why it's a physical change. Melting or all the phase changes are physical. Next question. The contact process is used to convert sulfur dioxide to sulfur trioxide. Vanadium oxide is a catalyst in this process. The forward reaction in this equilibrium is exothermic. Which statement about this process are correct? Now, this is a reversible reaction which is in equilibrium. They are saying that the forward reaction is exothermic. Which statements about this process are correct? The catalyst increases the rate of both forward and backward reaction. That if we add a catalyst, the rate of forward and backward both reaction increases? Yes, because both reactions are happening at the same time. So if we add a catalyst, both will increase also. The rate of both reactions will increase. Number two, a low pressure increases the yield of sulfur trioxide. Let's see. Sulfur trioxide is present on the product side, and as we can see, the product side has 2 number of moles and the reactant side has 3 number of moles. So here we have less number of moles. If we want a system to move to forward side to make more of sulfur trioxide, we have to increase the pressure because system will do in the opposite. If we increase the pressure, then system will move towards the side with the few number of moles, with the less pressure. Few moles, few particles, few less pressure. So this one is wrong. We have to use high pressure to make it move towards sulfur trioxide. Then a low pressure is used to keep the costs low. A low pressure is used to keep the cost low. Yes, it might be possible. A high temperature increases the yield of sulfur trioxide. This is also not correct because sulfur trioxide, this side, the forward side in which sulfur trioxide is being made, this is exothermic. So it means we will decrease the temperature so to keep the system moving towards exothermic side. We have to decrease the pressure, but here they are saying that high pressure is used. So that means it's long. So we need low temperature, and low temperature increases the yield of sulfur trioxide. When we lower the temperature, then system will move towards exothermic side and sulfur trioxide will increase. So the answer is 1 and 3. Number 17, the equation for the decomposition of hydrogen peroxide is shown. So you can see hydrogen peroxide is decomposing into water and oxygen. In an experiment, the total volume of oxygen produced is 100 centimeter cube. The experiment is repeating using 1 gram of solid catalyst. The other conditions are the same. Which row describes total volume of oxygen and the mass of the catalyst at the end of the second experiment? Okay, this thing is for sure that the catalyst increases the speed of the reaction without being used up. It increases the rate without reacting. So a catalyst mass will not change in the reaction. So if we're adding 1 gram of a catalyst, it will still remain 1 gram at the end of the experiment also. And it just increases the rate of the reaction. It increases the speed of reaction, means the reaction will finish like it finished earlier, but the volume of oxygen will remain the same because we have kept all the other conditions same. The volume of hydrogen peroxide was also the same, so that is why the oxygen which we get will also be same or constant. So the total volume of oxygen will be 100 and the answer is C. Question number 18, nitrogen reacts with hydrogen to form ammonia. In the presence of iron catalyst, the reaction is reversible. Which statement about this reaction is correct? Now the reaction is reversible and it is in equilibrium. Which statement is correct? The iron catalyst decreases the activation energy only for forward reaction. No, it decreases or it lowers down the activation energy for both reactions, as I told you above. For the rate of both reactions will get affected. So it lowers the activation energy for both, not only for forward. When equilibrium is reached, the forward reaction has stopped? Oops, no. When the equilibrium is reached, the forward and backward reaction keeps on happening. When the temperature changes, the concentration of ammonia at equilibrium remains constant. This is also wrong because the equilibrium position remains constant when the pressure on both sides is equal. When the pressure and the number of moles on both sides are same. But here the number of moles are not equal. On the reactant side, there are 4 number of moles, and on the product side, there are 2 number of moles. So the pressure is also different. The number of moles directly affects the pressure. If the moles are more, then pressure is more. And if the moles are less, pressure is less. So if we increase or decrease the pressure, if we change the pressure, then obviously it will affect the position of the equilibrium. Nitrogen and hydrogen never completely convert to ammonia. Yes, this one is correct because nitrogen and hydrogen, they are reacting with each other, forming the ammonia, but ammonia keeps on decomposing to form nitrogen and hydrogen again. And the forward and backward reaction is happening simultaneously. So nitrogen and hydrogen can never completely convert to ammonia because this is not a one direction reaction. Okay, if it would be one direction reaction, then the reactants are completely used up and completely the products are formed. But this is not the case. This is a reversible reaction. So they will never completely used up. Now question number 19. The equation for redox reaction is shown. Hydrogen peroxide plus potassium iodide plus sulfuric acid gives iodine plus potassium sulfate and gives water. Potassium iodide is dash agent in this reaction because iodide ions dash electrons. Okay. Now, in this question, we need to focus on potassium iodide. That here, the potassium iodide, what is happening to potassium iodide? See, iodine here in the reactants, iodine is negative, and in the product, there it is forming iodine molecule, which makes iodine at oxidation number 0. So basically, iodide ions, they are going from -1 to 0. -1 to 0, here the oxidation state is decreasing. From -1 to 0, okay, it's not decreasing. In -1 to 0, the oxidation state is increasing. And when the oxidation number increases, oxidation state increases, this is oxidation. Means iodide ion is getting oxidized. So iodide ion itself, it is getting oxidized, and the substance which itself oxidizes, it acts as a reducing agent because it loses electrons by itself, but it adds electron in the other. So oxidize means itself, it loses electrons. The loss of electron happens, it loses electron, but reducing agent is after losing electron, it adds electron into the other. So iodide ion -1 has extra electrons, so it is losing electron. So itself, it is oxidized, it is losing. Iodide ion is losing electrons, and they're acting as reducing agents because after losing, they're adding electrons into the other substance. So option C is correct. Question 20. Element E is in group 2 of the periodic table. Which row describes element E and its oxide? So group 2 is the group of metals, and the metals always form basic oxides. Because group 2 metals, they are also known as alkaline earth metals. And alkaline earth metal simply indicates that it forms base, or when we dissolve it in water, it forms alkalis. So group 2 element is a metal, and the type of oxide which it forms is basic. So the answer is B. We'll do the rest of the questions in the next video.